Hello, please welcome our next presenter from Cementos Argos in South America. Our two maulers will be Alfonso Ibarra and Hugo Caballero, and they will be talking about their cement supply chain scheduling in the Eastern Caribbean. So, welcome, Hugo and Alfonso. Hello, Hugo, you hear us okay?
Hello.
Hello.
Hello. Good afternoon.
Yes, and please start whenever you're ready.
Okay.
Okay, okay,
Sorry,
okay.
I thought it was a little bit delayed.
Yes, go ahead.
Okay. So today we're going to present to you our simulator for the Eastern Caribbean. We have an agent-based model for the bulk cement supply in the Eastern Caribbean. First of all, just to give you a brief introduction of who are we are Cementos Argos. We're a company based in Colombia. However, we operate across 16 different countries. We have different model lines: cement, concrete, and aggregates. We're also the fourth largest cement producer in the United States. I'm going to give you here we can see our print
Footprint.
footprint around Latin America, our Colombia region, our United States region, and Central America and the Caribbean. Today, we're going to concentrate on these islands over here: St. Thomas, St. Martin, Antigua, Dominica, Aruba, and Curacao. The general objective for this simulator is to develop and evaluate a simulation model of for the supply of bulk cement to the Eastern Caribbean terminals using AnyLogic. We defined several specific objectives to avoid cement shortages in each market, use 100% capacity for each of the vessels, and optimize the discharge times to avoid rotation delays or demurrage. So basically, we count with two bulk carriers, MV Cymbidium with 7,300 metric tons of capacity and MV NAC Panarea with 5,300 metric tons. Each terminal has a different capacity or storage capacity in silos, which have been considered on the model. Also, the draft restrictions for each vessel have been considered in the model. There's three terminals that don't have any draft restrictions. These are Aruba, St. Martin, and St. Thomas. Some port restrictions as well. Some of them operate on the weekends and some don't. And the operation in the terminal. As we act as wholesalers in each market, so we provide cement for both the industrial and retail segments. So, just to give you guys a brief introduction, usually our first stops would be Aruba, St. Thomas, or St. Martin, given that they don't have any draft restrictions. And usually the last stop would be Antigua, which has the lower draft. Of course, the local demands will determine the frequency of shipments and the cement volume per terminal. And also, those that have local production would have an increased storage capacity in terms of small bags and big bags. So previously, we modeled the supply of cement using 100% Excel files. So we have four different files where we download the sales and production, update the inventory report, and then produce the inventory planning for the coming couple of weeks. Basically, the vessel programming was done by estimating the tentative dates of arrival at the port of origin. Then we reviewed the next cycle based on this analysis in inventory planning, confirmed the product availability, and manually we will build up the supply program considering the system constraints. Now, these constraints are known by experience rather than modeled in some kind of system. And this gave us a visibility of only 15 days from when we did the planning until it was executed. So we clearly didn't have much of a visibility there. This model or this process was carried out on a weekly basis. This is the main interface of our AnyLogic model. On the last slide, we will show a video of how it operates. So basically what we have is the port of origin and the different terminals where we are supplying the cement.
Okay, our model is basically an agent-based simulation model, and this model is built as a final solution for the end user of the company, that is the people that is scheduling the vessels to the dispatch of the cement to the island. The deployment is done as a Java executable file. So this is more or less the screen that the end user see of the model. You can see here the supplier port, that terminal, that is Cartagena. Cartagena is a city in the north part of Colombia, and we have a huge cement plant in Cartagena, and that plant supply the cement for the island and the Caribbean. So basically, we move the cement from Cartagena to Aruba. This is Curacao, Dominica, and Tijuana. So the model basically tried to simulate the different location to the different terminals and the supplier terminal here. And the agents are the vessels. So now we have two vessels. This is the Cymbidium, and another one is the NAC. So this is the main interface for the model. The input data for the terminals, we have like one screen like this, where the end user enter the information for the simulation. In the terminal, we include the information for the initial inventory, projected demand for each product in each market. We also include the terminal parameters like storage capacity, packing rate, working hours, scheduling, working schedule. For the vessels, we have another screen like this. In the vessels, we include basically the route for each vessel, the proposed volume split, the ship speed range, and any departure delays we can consider in the model. As a parameters include inside the model, we have the vessel capacity, vessel loading and unloading rates. As you can see, we have a lot of parameters here. To do this more easily, we have the possibility to input the data of the model, reading the data from an Excel spreadsheet template that we have to do that. And the results of the model can be exported also to the same Excel file. So that make easier to read and write the results to the Excel file. The modeling approach, we have basically used an extensive use of the fluid library for the simulation of loading and unloading process of vessels and storage, okay, packing and dispatch of the cement terminals. As you can see here, we have, for example, the basic blocks for the terminal in Cartagena, that is the cement supplier. We use here the source element, valve, bulk conveyor, tanks, pipes, and one element important here is the exit element that allows to connect to the vessel. And this is basically the blocks for the vessel. The vessel is basically one tank that can be moving on the environment and the main agent. And, and here we have a valve to control the input rate to the vessel and another valve to control the output rate from the vessel to the terminal. And finally, inside each terminal, we have something like this. One enter element for connecting the vessel, valve and pipes, and the silo, the main silo as a storage in the terminal. We have also a split element that allows to produce the different presentation of the cement or the different products. For example, in this case, we are using this valve as a packing machine, and through this pipe we storage the packing cement in a warehouse that is represented here as a tank, and then through this valve we control the discharge as a demand of the market, simulating the demand of the market for that specific product, and then we go to to this specific product. We do the same for the big bags and the bulk in this case. You can also here, you can check here that we have some schedules. These schedules allows us to simulate the different working hours for the different process on the terminal. For example, we have a schedule to receive the vessels, for example, in one particular hour during the day, or we have one schedule to selling the cement in daily hours during the day, and we can include also weekends if we want for one specific case in one terminal. So this is basically what happened inside each terminal. The vessels, the approach is build the vessels and reproduce the behavior of one vessel using a state charge. So our model is an agent-based simulation. So each of the vessels are basically one agent, and the state chart reproduce all the behavior of the vessel. We simulate stochastic parameters like vessel speed, cement demand, and other parameters using the billing probability distribution that have AnyLogic, or we can use also custom distribution. So you can model those stochastic parameters. We are also using extensive use of functions, events, datasets, parameters, variables, and collection of elements. So we can reproduce all the complexity of the model for that specific case. And finally, the user have control of the simulation starting day and simulation time, so they can specify that during the process of starting the simulation. So this is one screenshot of the state chart for one of the vessels. Very quickly, if you can see here, this is part of the blocks that we use if we are run of cement inside one vessel. Then we continue with this road here and go to Cartagena to loading the vessel. And those elements here are representing the different states that one vessel follow when they go to one specific terminal. So here is the routine for loading one terminal with a specific cement. Okay. The output of our model is something like this. We have here one screenshot of what the user can see in for example in San Martin. We can see this information from the inventory, final inventory, sales per terminal, daily demand, and what is happening inside the terminal, if there is a shortage or not. For the point of view of the vessels, we can see this information. You can see information for both vessels, the Cymbidium and the NAC. You can see the scheduling, the arrival or departure in each of the terminals. You can see also, for example, if there is a run out of cement, and in what happened, in what moment occurs, and then it's supposed that the vessels should return to Cartagena. We can see here the profile of the velocity of the vessels, and we are monitoring also the draft constraint. So the idea is that the vessel can enter or not inside one terminal, depending or if there is meet the draft constraint or not.
So basically, what we were able to optimize using the model, the previous description of the model, we were able to extend the visibility to 30 to 35 days. Now we are able to construct and revise different scenarios without having the need, to build up different Excel files. Using this simulation, we are able to confirm the best option after constructing, after building and reviewing the different scenarios. After this, we're able to monitor the vessel program, and if there are any adjustments that have to be made to the initial program, it's easier for us to check those different scenarios and adjust them as the program advances. Now this process is carried out on a monthly basis rather than on a weekly basis, which definitely saves us a lot of time and a lot of difficulties. Our team as well, we designed some KPIs to be able to measure the simulator's performance and assertiveness. The different KPIs that we are describing here would be cement inventory breakdown, which is basically number of days without inventory, any loss of income for those days of breakdown, vessel capacity utilization, which is just to be sure if we are loading the vessel in total capacity, and the fulfillment of the supply program. Now, this fulfillment of supply program would assign a weight to different variables that intervene in the supply plan. These variables that we are considering are the date of departure from origin, the date of arrival to each terminal, vessel assignment, stop sequence, and the assigned volume to each terminal. So we, at the end of the simulation, we save this information and we compare to what actually is the final outcome. So far, we're fulfilling all these KPIs. We are keeping record of how we're performing at the moment, and definitely it has proven to be very effective. The benefits of the simulation model, it offers greater visibility of the operations. We have a broader horizon, and we're able to identify possible risks such as inventory shortage and be able to do any adjustments to avoid them. Time reduction in the supply scheduling process, definitely. A decrease in split changes, review of the system bottlenecks in a systemic and integrated way, improved product availability in real time, placing the inventory wherever it is required. We have identified also lower labor costs and overtime with a higher volume sold in 2021 and the unitary cost has been kept equal to what we had in 2020. Fleet use optimization, ease of knowledge transfer, as I explained before. The simulate before the constraints were implemented with previous knowledge of the, let's say, the users, but now that we have the simulator, it will provide the basis for those users that come new, let's say, to the simulation, and definitely an ease of scenario development, freeing the network restrictions.
Okay, we identify also the next steps in this process. Our improvement opportunities includes build one heuristic model for autonomous destination definition by vessel. So the idea is that each vessel can define what is the most suitable or the most optimal next destination. So this is we are now working on this. The idea is to work in one kind of automatic model. So the idea is that both vessels can define what is the optimal next destination. And then the other improvement is includes reinforced learning applied to those agents that are the vessels. So and improve the behavior. So we can combine even both ideas, and that is our next target in this process.
So now I'm just gonna show you a short video of how the program runs. And that has been modeled for this specific month. This is the supply chain simulator for the Eastern Caribbean operations of Argos Cement. I already uploaded the file from Excel, so here we have the initial inventories per terminal and the demand that has been modeled for this specific month. Start date and simulation time as well. On the next page, we can see the vessel rotations for Cymbidium and for the NAG, each with 2 routes. So I'm just gonna click run right here. On this main page, we're able to see how the vessel starts running to the different operations. We can check as well the inventories, the sales, the autonomy, and if there are any empty events at each operation. For example, in Curacao, we just had one empty event that lasted for 20 hours. We can as well focus on each terminal. Here we can see the flow chart for Dominica. This is an example of an operation that has local production of small bags, big bags, and bulk cement. This graph right here is very important, that shows how the inventory is performing, inventory in silos, inventory of small bags, and inventory of big bags. And we can as well monitor the sales per product for each territory. St. Thomas is a more simple operation that has only bulk cement. We don't have local production here. Same case for Aruba. And we can also check the ships, how they are performing, the arrival date to each port and the departure date to each port. The simulator also calculates the time of permanence at each terminal. This helps us identify if there are any delays or demurrage during the discharge of cement. Going back to the main platform, here we're able to monitor the vessel movements and identify if there's any opportunity of improving this rotation, mostly to avoid running out of cement at any given terminal. Once it's finished, we stop the process here and we go back to the Excel file where it's going to print out the results for us to be able to analyze and optimize the next scenario. we are able to compare the vessel performance against what we had scheduled initially. So the dates that we had scheduled against the date in and date out. And we can do the same thing for the demands. Based on what we have projected for each terminal, we're going to be able to compare how the simulator, or what the simulator results are. Thank you very much, and let us know if you have any additional questions.
Okay, so this is our model. Thank you for your attention, and if you have any question, we are ready to answer.
Did you simulate this model with several capacity and disruptions in the demand and supply? Yes, right now, what we usually try to do is to project what the demand is going to be for any given month that we're going to actually simulate. So, for example, now that we are in September, we will simulate the rotations for October. We already have an idea of how each market is going to perform. Based on that, we use a beta distribution with minimum, a mode, and a max that will determine at the end of the month how our sales are at each terminal, and also the capacities that each terminal can take will depend as well on this demand and also on the packing rates.
Okay, we have also the possibility to include custom distribution also based on the historical data. So we have both possibilities to work with billing distribution or custom distribution.
Okay, it seems we don't have much questions.
Okay, Hugo and Alfonso, very, very impressive model. I think more questions probably are coming in right now, but we're out of time. So please, send all your questions to their emails in your bios, and they will answer for you shortly. Thank you again. Very, very impressive.